Welcome to Get Real Health. I'm your host, Dr. Chana Davis. This show cuts through the noise to give you science-based insights from real experts so that you can make smart, healthy choices. Today's conversation is all about navigating the modern world through the lens of toxicology. I'm joined by Dr. Alison Bernstein, who's a professor of neuroscience and toxicology at Michigan State University. She's also a passionate science communicator. She and I have a common goal to help people minimize unnecessary stress while taking action to behave responsibly when there is a real stress. So we'll discuss some basic toxicology concepts today, including risk, hazard, and exposure, as well as the differences between natural and synthetic and when that division actually matters. Finally, we'll just make this real by bringing it into the grocery store, the kitchen, and the rest of your life. So Dr. Bernstein will share some of her personal habits that are informed by her research in the lab and outside of the lab. To learn more about Dr. Bernstein, check out her website at her lab or SciMoms.com. Dr. Alison Bernstein, thank you so much for coming in for a chat. You and I have a ridiculous amount in common, so I can't wait to dig in. I wanted to start with your personal journey and how you came to wear the two hats that you do, both as a researcher and as a science communicator.
So these stories kind of parallel each other. So I started my graduate studies in genetics and then became very interested in neuroscience. So most of my work was actually in neuroscience. And then towards the end of graduate school, I got pregnant. And so I was I was thinking a lot about exposures and keeping my baby safe through pregnancy and through her early development. And I also, in my research, was working on toxicants that increase risk of Parkinson's disease. So there was kind of this parallel thing happening in my life where my research was related to what my personal worries were. And then so I continued in that path of research. And then my science communication really started in 2015. There was the measles outbreak that started in Disneyland. And I just really started getting frustrated with all of the misinformation that I was seeing shared about that. So that's why I got into science communication and started my Facebook page, Mommy PhD. And then it sort of evolved into everything that it's become with the SciMoms movie and the SciMoms organization.
Can you actually tell us a little bit about the SciMoms organization?
Yeah, so we are SciMoms. So the documentary is SciMoms, and we are separate from that. So SciMoms was a documentary that Natalie Newell made about the five of us when she came across our writing. And through the process of going through the film and meeting each other in person for screenings of the film, we found that we really, not only do we like working together, the five of us just genuinely like each other. So we were like, we should work together more. And so it kind of came about organically. And so SciMoms is an organization. We have a website where we try to share evidence-based information for questions that parents have for everything from vaccines and medical choices to food and diet to trampolines and skateboards. So really a full spectrum of questions that parents might have.
I have to say, you are definitely one of my go-to sources, and it's amazing how often you have an answer or you're about to put out an answer of something that I've been thinking about.
That's
a lot of
most
parents share the same questions.
Yeah, and a lot of people now have started messaging us, and that's why I think when you come to us and we've already done it or we're working on it, it's because everyone has the same questions. So if someone's emailed us, we do our best to get to it quickly.
I love it. So can you elaborate a bit more on your content expertise, I guess, and a little bit more about why you're so familiar with these topics and what allows you to answer them?
So sometimes we are writing about things that are not directly our own expertise. And that's why we always, even if it's in our area, we always find the experts and cite them. Like, I'm not an expert on trampoline safety, but I've written a post on trampoline safety because my son broke his leg on a trampoline. And so we turn to the American Academy of Orthopedic Surgeons and the American Academy of Pediatrics. And so we go to the relevant authorities who have that expertise, and all that we're doing is providing for parents where they can find that information. And so where my expertise is, my PhD is in genetics. I have neuroscience training in graduate school, and in my postdoc training, I also have postdoc training in toxicology. And now I do mostly neurotoxicology research. So my expertise is broadly in biology, more specifically in neuroscience and in toxicology. So understanding exposures and how that affects our health.
Well, that's a great segue into what I wanted to do next, is to allow people to have a bit of insight into Toxicology 101, essentially. So what are some of the basic principles of toxicology that you feel that the general public doesn't necessarily understand and would help them make more informed choices as they navigate the modern world?
Yeah, so some of this is toxicology and some of this is risk. And so I'll just give a little plug to our Risk in Perspective series that we have on our blog for some more details, because I can't cover
I love that
all.
series, by the way.
Good. We spent a lot of time on it. And actually, I'm preparing a session for the Society of Toxicology meeting in a week and a half, kind of based on that series. So it's sort of launched a whole, it's launched a lot of opportunities, which is great. But so the first thing that I think people don't know, because this isn't something that we normally learn, is the difference between hazard, risk, and exposure. So a hazard is anything that could cause harm. So for example, there's a mug, like a vase, up on the shelf behind my computer that you can't see. It's a hazard because it potentially could fall on me. But it would only be a risk if something is there to push it to fall on me. That's not the best analogy, but I think it illustrates what I'm trying to say. So hazard has the potential to cause harm. Risk is the probability of harm occurring. So risk is just a measure of chance. How likely is it that that hurts you? It doesn't tell you anything about how harmful it is. So risk could be risk of a rash or risk of dying, but the risk itself doesn't tell you anything about the severity of harm. And then the exposure is that you are coming into contact with that hazard. So I think the example that we used on the website is that sharks are a hazard, but if I never go in the ocean, I have no risk because I have no exposure to that shark.
Right.
So
and the risk of the shark would be, it would be pretty bad because you could get bit, or like what would be, is the risk sort of the worst case scenario thing that could happen if you were exposed?
No, the risk is a measure of probability. So if I have no exposure to a shark, I have zero chance of being hurt by a shark. If I'm in the ocean, maybe I have no idea if this is accurate, a 2% chance of being hurt by a shark. It says nothing about what that hurt is. It doesn't tell me if it's getting bashed by a shark or eaten by a shark.
So where does the severity come in then?
There's not really a measure for it in that framework. So we have a quadrant, and unfortunately I can't show you right now, but if someone goes to the risk series, SciMoms.com/risk, we have a quadrant diagram that talks about the number of people affected and the severity of harm, and positions hazards on that quadrant system. And so that's sort of where severity is. And where that comes in is when regulators think about what we should do, or where we as individuals think about what we should do. You know, I'm not going to be as concerned if something is very likely to give me a little bit of skin irritation. We're not going to do the same thing as something that's very likely to cause cancer. Right? We're going to have different responses to those, even if the probability is the same.
Right.
So the other thing is that we often see exposure reported as adverse health effect. So adverse health effect means that something bad happens, and exposure is different than that, right? Because you can be exposed to a lot of things that don't affect your health, but understanding exposure is very important to understanding risk because of its relationship.
A word that we hear a lot is, chemical free. So maybe there's the chemical, and then there's the sort of the division that I think that we see in the public a lot between natural and synthetic. So that whole discussion.
Yeah, that's a really important one. So I think people hear chemical and they think dangerous, they think risky, they think adverse health effects. But in reality, everything in our environment is made of chemicals. So this statement that chemicals are dangerous is not actually accurate. But then there's other people who are like, oh, a chemical's a chemical, and I've said that myself. And it's not necessarily that helpful, because when people say chemicals are dangerous, they mean a certain type of chemical, right? Mm-hmm. So some of it is a specificity of language, but I think it's important because, like, people say chemical free anything, and that's
soap or whatever. They might say chemical free soap.
It has chemicals. Some of it's okay, and just this needless fear is not helpful. And I think understanding the distinction between chemicals that are harmful and at what doses they're harmful is very important to help people feel more empowered and in control, versus just sort of like, I live in a chemical soup and it's all going to hurt me. Mm-hmm. That's a very scary place to think that you live.
Yeah, since I've started to live in this, spend more time thinking about, safety and exposures and, chemicals in my own environment, my favorite phrase is the dose makes the poison. And mm-hmm. I see that, understanding that concept is so critical. Yet it's so rarely appreciated and brought into the conversation.
And that is a very traditional tenet of toxicology. And within that, there's a lot of nuance. So the dose makes the poison, but not all dose response curves are shaped the same. So regulators are trying to figure out, especially as we figure out in recent years that some dose responses are worse at lower doses, but eventually they're back down. So how do we accommodate that into the regulatory framework? Also, we're finding out, I shouldn't say we're finding out, we've known this for a long time. There are a lot of exposures where a lot of people are exposed, but only some people who are exposed have an effect of that exposure. So what is the dose interacting with? So we have genetic susceptibility, you have all your other exposures, and that's called the exposome, and we have the microbiome, and we have the epigenome, and we have all these other omes. So it's really the dose in interaction with all of these other omes.
Right.
And
right.
So trying
You're saying it's hard to have a single dose curve. There's not one that applies to everyone necessarily, because there are, like, I'm thinking about we were just chatting this morning about coronavirus and, mm-hmm. Susceptibility in immunocompromised people.
Yeah. It's very complicated. And then I wanted to get back to, you mentioned before, this difference between natural and artificial.
Yes.
And I find that in online conversations, I find the whole conversation frustrating, because I feel like nobody's having the nuanced discussion that this deserves. So yes. Clearly, synthetic does not necessarily mean bad, because I can make vitamin C in a lab. In fact, I have some in my lab. We use it all the time. I can also get vitamin C from an orange. That vitamin C is identical. It's identical to all the cells in my body, and it has the exact same effect. And the fact that it was made in a lab and that it's artificial tells me nothing about its chemical properties. Mm-hmm. However, there are some synthetic chemicals that are made that have no equivalent in nature, and thus there's nothing's evolved to get rid of it, to clear it. So those kind of chemicals, we should be a little bit more concerned about, because they are synthetic, right? So those are things.
I think the trans fats are a perfect example of that one.
And I was going to say, because I work on persistent organic pollutants, so organochlorine pesticides is what I work on, but it's also related to PFAS, which has been in the news a lot lately. And because I live in Michigan, it's related to PCBs, which contaminated the Great Lakes for a long time. PBBs, there was a huge accident in Michigan in the 1970s. PBBs are flame retardants, where they were accidentally mixed into cattle feed. So those flame retardants got into the food supply. And so basically everybody who lived in the lower peninsula of Michigan in the 70s was exposed at very high levels to these chemicals. So all of those chemicals have a specific chemical structure in common that does not exist in nature. Mm-hmm. I think there might be some very, very rare cases where it exists. Right. So there's nothing that breaks it down in the environment. So it's just sort of there.
I guess that speaks to one of the things I was hoping we would cover is how does the FDA or how do these organizations assess the safety of a compound or safety or toxicology and determine a safe dose? And can you believe it? Because a lot of people just say I don't even trust the government no matter what because they've messed up before.
Yeah.
How does that come into the conversation?
There's a few things here, so I'll try to stay on track. So first, I would say that we have to separate what the science says from what regulators do. Because science is the science and it is what it is and it says what it says, but what regulators choose to do on that science is somewhat of a separate issue. So regulators don't always follow the science. I think the lead in Flint is a good example of that, where scientists were saying, hey, there's lead, and the regulators didn't want to listen. The scientist said, you can't send it through those pipes, there will be lead. And the regulator said, or the government said, we're going to do it anyways, right? So the science is what it is, and regulators are supposed to make decisions based on the best science. So with that said, what the science can tell us are various metrics. So we can do experiments and we can do epidemiology and we can do toxicology studies, and we can say when we do in vitro studies in animals and we give this much and we do a dose response curve, which means we give different doses of a toxicant to an animal and we look for specific effects, we find the lowest dose at which we see an effect. And that's called a Lowell, lowest observed adverse effect level. And there's also a NOEL, which is no observed adverse effect level. So you're finding the lowest doses before there's an effect. And then what regulators do is they take that and they divide it by what is known as uncertainty factors. And so this will often include a factor of 10 if it's based on an animal study, because we don't know the difference between humans and animals. There are other uncertainty factors for various things like that. And so the safe limit is usually at least 10 times lower than the no effect level, but often much lower. And one of the questions, to go back to the dose response curve, the shape of the bottom of the curve that I talked about, there is some question over whether we should be more conservative and have the regulatory limit be even more.
Right, so it's padded. It's padded sort of by 100-fold based on what you see in animals, or 10 to 100-fold. But some people think it should be padded even more.
Yes, and some of that has to do with to what bottom level of risk we should be regulating to.
Right.
So we can't really ever regulate to zero risk. That's not a realistic goal. But how low should we go? What endpoints should we consider? So traditionally, because it was all we really could do, they were looking for genotoxic things, so things that cause mutations that cause cancer. And that was the only thing that was looked at. And over time, we've added more and more endpoints. So now we look at things like in my field, like neurodevelopmental toxicology. So that's now incorporated into these things. So over time, we can consider more outcomes, we can consider more adverse health effects, and we can build in more safety margins. But the regulatory trends in the US have kind of gone the other way because of politics.
So the other way in terms of, other way of not cushioning very much? Or
they haven't changed how much we cushion, but how much things are enforced and whether the government is willing to put in new regulations.
Okay. But just backing up to, if you were to actually look at a report, a government sort of safety assessment on a compound, what would be the sort of components of that report? You mentioned the animal models, and you said maybe there'll be some, you mentioned epidemiology, but you didn't really explain that sort of the human data considerations that go into that, and then the sort of the in the dish kind of experiments we do.
Yeah. So the in the dish and animal experiments get you these metrics, because you can't do those experiments in humans. It's not ethical. To just expose people to a compound that is dangerous. We can't do those studies. So what we use the epidemiology for, is to look at what human exposure levels are. So then what regulators are trying to figure out is how does human exposure compare to these metrics that we've figured out. And so
Mm-hmm.
then they're trying to decide, what should we do? People might be exposed, but it might be so far below the metric that you don't do anything.
Mm-hmm.
Maybe the human exposure is way above that metric, and then you need to take action.
Right, right.
So,
But you might also, like, I forget which chemical I was looking at. It was one of these, maybe it was arsenic. Sometimes you do have sort of accidental human data of people that have been
yes,
exposed. With heavy metals, you'll definitely see a lot of that.
yes. And so sometimes, unfortunately, you do have that data.
You have
Because-
miners or something, and you can look at what happened.
Yeah, and so that's where using these kind of exposed cohorts is really informative. So
Mhm.
you have these tragedies that happen, like lead in Flint or PBBs in Michigan, or specific occupational groups like miners or something like that. And those can tell you a lot about what happens at usually those are fairly high levels of exposure that aren't what's happening to the rest of us.
Mm-hmm. So just, again, taking it back one level, you were saying the government figures out whether or not to take action. So is it the case that, again, some substances people can put as much as they want into your food or whatever, and others there's a regulated amount? So just backing it up a level, is that a fair statement?
So we actually have a post on SciMoms about this also. How safe is safe is what it's called, I think.
Okay.
And in it, we discuss how they define these safe levels. So the first thing is that safe doesn't mean no risk. It means it meets some criteria that we have defined as minimally risky.
Okay.
So for the food supply for the FDA, that's something called GRAS, generally recognized as safe. And so that's just things that people have been consuming forever that are generally recognized as safe. Like, I think that exactly what it says.
Right. So it's hard to argue that it's unsafe if we've been eating it forever and no one seems to have problems when they consume it.
Yeah. And so there might be some low level, like we talked about, individual susceptibility and the interaction with genetics. Like peanuts are generally recognized as safe, except that some people have deadly peanut allergies. So even within those things, like there's some wiggle room, but generally recognized as safe is, and I don't know, actually, I should clarify, I don't know if peanuts are classified as generally recognized as safe. It was perhaps a poor example. One thing that just came up recently is I have some tummy issues, and I was looking at a product called IB Guard, which is for IBS, irritable bowel syndrome. And it's basically like peppermint capsules, because peppermint helps with tummy distress. And I was looking into it, studies on it, because that's what I do. And it's a medical food. And so it's not FDA approved, because medical foods don't have to be FDA approved like drugs if they only contain GRAS ingredients. And so because it's peppermint oil, and people have been drinking peppermint tea, and peppermint has been a normal part of our diet for a very long time, that's considered safe. So those are the things that can go into our food supply without any specific testing. And there is a process to make sure. Like, it's not just like a company could be like, oh, we say this is GRAS, so it's GRAS. There's a process for demonstrating that that's the case.
Yeah. I was going to say, I feel like there's a lack of appreciation for the other side of the natural synthetic divide, being that natural things can be dangerous if you go bananas, like an all kale diet. Certain, brassica can be goitrogens, and if you go bananas on anything, you can get in trouble, including these natural remedies, right?
Yeah, and like we just had a potato that we let sit too long, and I cut into it, and the whole thing was green, and that means that it now contains solanine, which can make you really, really sick. So that potato went in our compost pile.
Yeah.
But yeah, this comes up a lot with natural remedies. So one particular really scary story is these homeopathic teething tablets, which, so a homeopathic remedy should technically contain nothing. Like it should have, the principle of homeopathy is that you dilute so many times that there's nothing left of it, and that the water then has a memory of what you diluted it in. So I'll just put my plug that for homeopathy to work, everything we know about pharmacology, toxicology, physics, chemistry, and biology would have to be wrong. So that's my bit about homeopathy. But so these companies were selling homeopathic teething tablets, and they didn't even do the homeopathy right. So they didn't dilute the substance properly, and the substance they were diluting was belladonna, which is a highly toxic natural substance. And so babies have died because their parents are like, I'm going to give them this. It's natural. It's homeopathic. It sounds lovely. And then kids are dying. And there's really, these things aren't regulated at all.
That is really
And so
scary.
there's no one regulating to make sure that what is in or not in the product is actually what's in or not in the product. And there's no testing beforehand. Wow. So it's terrifying.
Yeah, well, that's a good segue to, I wanted to sort of wrap things up by bringing it into how do you apply this in your life? How do you use your scientific knowledge to navigate? So a couple of situations for you. One is the grocery store. So when you go to the grocery store, are there specific things you are more or less inclined to buy because of your understanding of toxicology?
So I don't worry about pesticide exposure, even though I study pesticide toxicity. I also realize, aside with coronavirus, I keep touching my face. And I shouldn't do that. So if we're going to talk about what I do in my own life, I shouldn't touch my face. Number one, don't touch your face. Don't shake hands. Wipe things down in the days of coronavirus.
So I don't under this. The face thing, is that just that you've got this sort of these entries points on your face? Is it because
you have entry points on your face? And so if your hands have touched things, it's much more likely to get into you. So I've just been super focused on how much I touch my face.
Interesting.
So when I go to the grocery store, I don't follow the dirty dozen. I don't worry about that kind of thing. I do try, if I can, I buy a lot of produce, because buying more produce and eating more fruits and vegetables is always a good thing. If I can get domestic produce, we try to do that, because the U.S. has some of the strongest pesticide regulations. Yeah. And so sometimes if you don't know where things are coming from, they might not actually have as strong regulations.
Yeah. I've actually looked at some regulatory reports on specific compounds where they test, hundreds of products, and the Chinese ones do scare me sometimes. Yeah. I see big differences in the spot testing reports.
And in the U.S., you can look up all these reports, like all those pesticide reports. It's available on the EPA and the USDA website, so it's there for you to see and look up. And we can't do that for all other countries where our food's coming from. So I try to do domestic as much as possible. But that is also less about me, because I'm going to wash my produce, and more about the workers, like that occupational exposure to those pesticides in a country where they don't have strong regulations.
Right.
So most of our grocery list is produce. We try to keep added sugar, to a minimum. And so we're not limiting fruit to limit sugar. That's thinking about added sugar. So I try to get my kids not to add honey to all their yogurt, because it's already sweet. They don't need more sugar. And so I mainly focus on sugar, eating a lot, reducing sugar, buying a lot of produce, and added salt is another one that I look at. And other than that,
great.
I don't worry.
What about I would very similar to you, very similar shopping habits, mostly produce. I pay more attention to local, just to, again, sort of from feeling like just to supporting the community. And I know you've written about the environmental impact of local not being necessarily what you think it might be, but we'll table that discussion for another one. But yeah, to factoring in different considerations besides the pesticide one are actually more impactful.
And we don't buy bagged lettuce, if you want to talk about food risks other than pesticides. So bagged lettuce is, think of all the foodborne outbreaks that have happened in the past couple of years. Like a lot of them come from pre-washed stuff and bagged lettuce. So I find, just from a cost thing, the bagged lettuce goes bad more quickly. So that frustrates me, because I only like to go to the store once a week. And
why would it be more likely to be? Is it just because you don't wash it then, and so it just washes itself?
I don't know. I don't know if it's more contaminated or it's something through the processing facility, but it's just, that's where, and it's not just bagged lettuce. We don't buy romaine lettuce anymore, because that one just seems to be always in the news. So we buy green leaf lettuce.
Interesting, yeah. I mean, I feel embarrassed that I didn't sort of twig on this earlier, but the contamination it's all coming from the nearby livestock. It's coming from the fecal matter in the animal
Um,
industry, is it
maybe it
not?
might be in the bag lettuce. It's going through a processing plant, so maybe it's coming.
Right.
Like there are a lot of potential places
But
where
these are
that's coming.
fecal contaminants essentially, right? These are like E. coli,
This I'm not
salmonella.
so sure about. So this
Yeah.
part I'm not so sure about.
Yeah. We should
Uh,
we should do sort of a I guess this is the toxicology discussion is a bit different than the food safety discussion,
yeah,
right? And
yeah.
that's
So where
something that
food
deserves its
safety
own
and
discussion.
toxicology overlap is sort of the pesticide residues, and
Mhm.
I don't really worry about that
Mhm.
so much. I wash my produce
Yeah.
partly because of pesticide residues, but mostly to reduce bacterial contamination.
Now, what about when it comes to food preparation? Because you do research plastics, that's something that I'm very curious about. And I've heard, for example, you shouldn't microwave your plastics, or maybe don't
Yeah,
cook in certain type of cookware.
yeah. So I cook mostly in a cast iron or just stainless steel. Um, and then I have one like really nice enamel coated.
Yes, like Le
Yeah,
Creuset, kind of.
yeah, it's
Mm-hmm.
really nice. But it would be very expensive to have all my whole cookware set be like that.
Yeah.
So mainly I use the cast iron and the stainless steel, and we do a lot of roasted veggies. And I put down aluminum foil because then I don't have to wash the pan
Yeah.
with all the oil. But yeah, I've gotten rid of most of my nonstick at this point.
Mm-hmm.
I don't heat plastic, so plastic doesn't go in the microwave. So even if I make a microwave meal, I dump it into a Pyrex container
Oh,
and
okay.
microwave it in glass, which might be overkill, but it's a very simple thing, and I don't know if it's actually doing anything, but it costs me nothing to do that.
Yeah.
Um,
But
and so I don't.
so what is the rationale behind that concern?
So people are concerned that when you heat plastic, any of the potentially toxic chemicals like BPA, phthalates, these plasticizers would leach out into your food.
Mm-hmm.
And so if you store it in plastic, it either doesn't leach or it leaches much more slowly, so you get a lot less in the food. And so if you heat it in not plastic, you don't get that leaching of the chemicals.
I see.
So I don't microwave any plastic. I don't put plastic. I occasionally put plastic in the dishwasher if it like needs a really good cleaning. But generally I just use hot water and soap in the sink.
No. So if it's all about the heat, then what about plastic water bottles? Any reason? I mean, besides environmental, to be concerned?
I mean, I think the environmental reason far outweighs
Yeah.
the toxicology.
I'm talking about like maybe the reusable plastic one that you carry
Yeah,
around
yeah,
with you. Is a lot of people are
yeah. Oh,
shifting
the
to carrying
reusable
around
ones?
glass. Yeah.
Um, there's some difference in the types of plastic that I'm not sure of.
Mm.
I have a really nice metal water bottle that I got as some swag at the Society of Toxicology
Yeah.
meeting. So I use that. But I
Yeah.
also have a glass one. It's really heavy, so it's not convenient. And
Exactly. That's why I've been sort of
yeah,
struggling with that one.
yeah. Yeah, I think you could probably look into the different types of plastic because certain types of plastic have more or less of these and leach fewer chemicals, but I haven't looked into that specifically.
Yeah.
We have a lot of the metal ones, like those Hydro Flask is a brand that we have,
Mm-hmm.
and I have this metal one, but they are heavy. And so when my second child was born, so in 2013, I was in a very anti-plastic, plastic is going to kill us all mindset. And so I had these glass baby bottles.
Yes.
And so I felt very like I am doing the thing and he's going to be perfect. And he's so much sicker than he's not sick. He's a healthy kid, but like he just gets more colds and he's just more of a mess than my daughter. But I gave him glass baby bottles, but they were such a pain in the neck.
Yeah, I had some of those and I rarely use them actually.
Yeah, I mean, they were nice because I could put them in the dishwasher, which made things a little bit easier. But it took him, he couldn't hold them. They were so heavy.
Yes.
So it just, yeah. If I had to do it again, I would use plastic.
Really?
Yeah.
One thing, I heard someone say that they don't drink out of to-go cups. Again, environmental question aside, you're drinking a hot beverage out of a little plastic lid. is that the kind of thing that would cross your mind to be concerned about, or does that just seem
It
totally?
never occurred to me until this very moment. Because it's
Okay.
not like it only passes through that lid while you
Yeah.
drink. Like if the concern is that the heat is making it leach out, I would be maybe concerned about it sitting in a hot plastic cup,
Right.
because then it's immersed, but just
Right.
passing through that lid.
Right. Man, you could just worry yourself to death. So I wanted to wrap up with maybe just get some sort of one-liners from you. I'm going to fire you 2 questions, and I want you to give me sort of a one-word answer or one-phrase answer if you can. So if
Okay.
there's one thing that you would love to see, parents and others stress less about, what would it be?
Everything. I think I think we put so much pressure on ourselves, and I think
Mhm.
we underestimate the effect of stress on our health, the effect of stress on our parenting, and the effect of our stress on our kids.
Mhm.
And
That's a great
so,
one. Okay, well, then I might know the answer to this one, but on the flip side, if there's one thing that you think people should be maybe more leery of than they are, is there anything that people are maybe under cautious about, that you're more cautious than others and you feel that is warranted?
flu and colds, like,
Mm.
in the midst of this coronavirus outbreak, everyone's washing their hands. And like I said, I'm super conscious of, am I touching my face? And we probably should be doing this all the time during cold and flu season. And it's only this scare that's making us do those things.
Mm-hmm.
And that doesn't mean you need to run out and like buy out the supply of hand sanitizer. Just wash your hands. You don't need antibacterial soap. Soap and water is antibacterial.
Okay. Well,
So
that's a great note to close on. Wash your hands. I'm going to go do that after the show.
yeah,
Well, thank you, Dr. Bernstein, Allison, for being on the show. It's been really fun chatting with you.
it has been great. Thank you for having me.
I'll be keeping an eye on your SciMoms content for sure. You guys are always answering my questions
I hope we
right on
can
the
keep
money.
doing
Okay,
it.
take
Okay.
care.
Bye.
Bye.